All right, so homework questions number 1 and 2 from section 8.2. We're talking about transformations of logarithms. So let's take a look at 1a. So 1a, it says here, describe how the graph of each log function can be obtained from the graph of y equals log of x base 5. So that's our base function. And what are the parameters? How does it change the graph? And we just need to describe. So what we have here clearly is we have a minus 1 in with the x. So anything in with the x, you know, either stretches horizontally, like in the x direction, or it moves it horizontally in the x direction. So anything in with x affects the x values. It's sideways, horizontal. Okay, think of that x-axis. So we know that as well, if we have a minus 1, the actual h value is plus 1. So it moves to the right, okay, moves to the right 1 unit. And also, put a little comma there, and also we need to examine the k value, and the k is plus 6. So the k value moves things either up or down. So because it's a positive 6, this also moves the graph up 6 units. Okay, moves up 6 units. What about B? Okay, what about B here? So 1b, well, we have an a value of negative 4. A is negative 4. So if you remember what happens with a, it stretches it vertically. And of course, if we have a negative a value, that flips it around vertically. It flips it vertically as well. So this is going to be a reflection in the x-axis. So that's what the negative 4. So a reflection in the x-axis. It's also going to be stretched vertically by a factor of 4. So if we have this as our graph, let's just say here, okay, it's going to be flipped vertically. It's also going to be stretched vertically. Okay, it's going to be times 4 here, right? Times 4 here. So stretched vertically as well. Anything else? Oh yeah, we've got a b value there. So what does the b value tell us? The b value, because it's greater than 1, does it stretch it out or does it compress it in? B is kind of the opposite, right? So it's going to be compressed or stretched by a factor of 1 over 3. I'm going to say compressed because I like using that terminology. You can tell it kind of gets squished up. So compressed by a factor of 1 over 3. So it's compressed in to exactly 1/3. So that means if I'm looking at this graph that I've drawn here, and I'll maybe change color to blue now. So, oh, this is going to be pretty tight, but everything is going to come in by a factor of 1/3. 1/3. 1/3. This one is going to be, in 1/3 towards this point here. It's going to be squished up like this. Okay, or maybe this way, I guess. Okay, compressed by a factor of 1/3, and I should say horizontally. Compressed horizontally. All right. So that's A and B for 1. I'll let you do C by yourself. That's got a little bit of everything there. But maybe I'll take a look at 2 here, just to give you a heads up here for 2. So 2A says sketch the graph of log of x base 3. Now, it would be a good idea to make a little table of values and take a little bit of time to do that. I'm just going to copy this and start again down here. Whoops. Control. Oh, what's going on? Control C. There we go. Control V. Thank you. So number 2, we're going to have a graph like this. Sketch the graph of log of x base 3, and then apply in order these transformations. So let's say x and y. I'm going to plot some points here. What about if I have negative 1 for x? Oh, can I have that? Ooh, I can't have that. Negative 1? It's a logarithm. Hey, that doesn't work, right? So that's undefined. So we're not going to have any point there. So I can't 1. Can't do 0 either. Let's go positive 1. Okay. The log of positive 1, so that's like 3 to what power gives us 1? Oh, that's tough too. Let's go 1/3. Okay. So the log of 1/3 base 3, that's 3 to what power gives us 1/3? Well, that's going to be 3 to the -1, so it's -1, right? Okay, so we've got x is 1/3. Here's 1. X is 1/3 and y is -1. What about if x is 1? If x is 1, that means 3 to some power gives us 1. Well, 3 to the 0 gives us 1. Okay? And then let's go 9. Okay? So log of 9 base 3, that's 3 to the power of what gives us 9? Well, that's going to be 3 squared. So if I've got 9 way over here, I've got 9. That's going to be 2. And then 3 would be 3 to the power of 1. So here's 3, so that's going to be 1. So we're kind of picturing our graph looks like this. That's what a log graph kind of looks like. Okay? Not a very good drawing, but. So let's apply transformations to this. Stretch vertically by a factor of 2. No problem. The 0 gets multiplied by 2. What's 0 times 2? 0. What is 1 here? Remember, we're stretching vertically, so we take the y values. What's 1 times 2? Well, that's 2. What is 2 times 2? That's 4. So we go up to 4 all the way here. What is negative? What was this, -1? -1 times 2 is -2. So that doubles down here. So here's what we have now. We have this. It's a stretched. Okay? So that's A, or the first part for A. And translate 3 units to the left. So we're going to take this graph and we're going to translate everything 3 units to the left. So 1, 2, 3. Okay, so that's -2. And again, 3 units to the left. This is a bit tough. My scale is pretty bad, but 3 units to the left, this is going to go to 0 and so on. So it's going to look something like this, right? 3 units, everything is over 3 units. Those should all be the same length. Okay. So there you go. Here's our final graph. Here's that last one we drew, and that's how you do number 2. Okay. And for B, let's finish off with B here. Write an equation of the final image, transformed image or transformed graph. An equation. So vertically by a factor of 2, that's A equals 2, right? And translate 3 units to the left, that's H equals -3. So our graph is going to be y equals, we need 2 log x base 3. And when I move it 3 units to the left, inside the brackets, that looks like an x plus 3. And there you have it. Stretched and moved over.